Okay, so we started the class last week, and I uploaded the week one lecture. I uploaded the week one lecture into the OneDrive, and at the same time, I uploaded into the Vimeo the video, and so that it doesn't require permission. I got few requests about the permission issues, but I think I tried to make it, open to everyone, but somehow it just by default asks for permission kind of thing. But hopefully it's settled now. If someone needs to start from the very beginning, so please go through week one lecture and the lecture slide. Sorry, the website, mainly the LMS, regarding the content of every week's. And today in the lab, we'll go through week one and week two lab together. And there are two exercises we need to solve during the lab. Okay. If you have any question, you can talk, or you can um, just probably try to write into the chat. So it should be fine. Sorry, just one thing. Okay, now in this lecture, we are covering about the variables, statements, and comments is the first half, and expressions in the second half. So before going into that, this is the overview of the Python language or any programming language. We discussed on the first lecture that I think the sound is okay, right? If you have any issues, please write it down, or you can talk. You can hear the sound. Okay, excellent. Now, if you look at this particular slide, we can see that any programming language is the high-level language, and specifically the Python is a third generation language. So in third generation language, the language style is similar to our own language, English or any other language, the way we write it down, with some exceptions. For example, the statements are slightly different in terms of calculations, because, for example, if we write x equal to 2, this is how actually we write always, right? We try to explain a number assigning to a word or to a letter in this particular way. We don't really say 2 equal to x, right? We say x equal to 2. We know that from the very beginning of our childhood, for example. But this one is a pretty much new, that sum equal to x plus y. And the notation is that the addition of x plus y goes to the sum, right? We'll actually look at that more in kind of programming point of view. And we print the output of the sum. Not exactly English. It is not exactly English, but it makes sense, right? Why does it make sense? Because if you look at the next stages, then it will be clear that it is actually better. The left portion is better than the right portion, right? So this is a high-level language, and example is a Python. And when we do the Python compiler, right, the Python compiler transform that language, that code that we are writing, into a intermediate object code. And this object code is similar to assembly language. This, again, I'm repeating that, this object code is similar to assembly language, right? And with the linker, that is a component of the compiler or any high-level language, it is transformed into the binary language. It is transformed into the binary language, and the binary language the machine can easily understand, right? So this is how the mapping is happening. Now, in case of fourth generation language, sometimes I talked about on lecture one, that App Inventor or some of the other high-level language like rational rows, in which you can write or scratch. I never tried Scratch, but if you search in Google, you can find that some of the programming language you can write using the block, right? Just you can drag and drop a block, and the code is ready to go, right? So this type of fourth level language, in fact, transform to a third generation language. Then the rest of the steps are exactly as it is, right? So this is the flow of any high level language to the binary language and so on. Okay. Okay, the lecture slides will not be uploaded. So I think the coordinator told me that we should not make it open, right? Sorry for that. Okay, now, so only from the lecture, actually, you can get that. Okay, now this will be recorded and uploaded into the LMS, and any question you can write into the chat. So by the end of the week 2, you should be able to write simple statements and expressions, use sensible variable names and comments to improve the readability of the code. And this is one of the very important concern in the programming. When a programmer works in a team, then the readability of the code is vital. And some companies have their own kind of rules to ensure that every programmer is maintaining the readability of the code. We'll learn on that, specific to the Python language. Okay, and understand the difference between integers, floats, and strings, right? We'll go through that using the code straight. Okay, now we'll cover literals and variables, statements, and naming conventions and comments. So the first one is the literals and variables. So what is literal? So literals are values that Python interprets literally as written. Okay, so represent numbers, text, and other values that are required by the program and known ahead of time. For example, a calendar program might contain string literals such as Wednesday and August, right? It makes sense. So these are the word or text that we are using in a calendar program, for example. So every program has their own type of, words, which is a sensible words or literals, we can say. Now, numeric literals. So literals can be two type. One is numeric and another is a string. So numeric literals are written as you'd expect. So for example, 42 means the number 42. So if we write, so this is the Python, right? We know that this is the Python. However, what we suggest is to use the Google Colab, right? So I can share the screen just to get an idea of that. So if you just search the Google Colab that we discussed last lab, so if you click that, you need a Gmail to access to the account, and then probably you can come across a page. I mean, this is one of my opened kind of Python under the Google Colab. So you can make a new kind of file. So for example, if I just jump in, so I just probably what I can do, I can share the screen. That should be easier. So yeah. So okay. So again, I'm going back. So if I click that, then you can see that that Google Collaboratory will come, and you just click the Open Collab. Then you can expect something like that. So this is a recent file, so you can click any of that, and then you can find your uh, IPYNB file, right? IPYNB is the extension of the Python file. So I just put those codes. So whatever you put, it should be staying. And if you want to include a new line, what you can really do is that you just hover the mouse on the last line of code. Either you can edit here, or you can just simply go there, hover the mouse, and then code and text. So if you click the code, you can start the coding here, right? So if you just try to compare the 42, so you can see that this is the 42. So if I type and run it, so this is nothing but the 42. So this is a kind of number, right? So this is exactly as that kind of thing, triple kind of arrow. Another thing I'd like to do, sorry, okay, so another example I would like to do is this one, right? So if you simply just type in the command cmd, so if you just type the command, then if you type the Python, you can see that will appear, and then you can type the 42, right? And then you can get exactly as it is. So you can just try to assume that we are basically playing here. So I'm just trying to make it simple to everyone. I'm just sharing the screen in this way. So for example, if I just try to compare in this way, and keep side by side, and then it will make sense. So just again, go here. So whatever I'm typing in, you can exactly type this thing either in Google Colab. You need to click the the play button, or you can in the command prompt you can type Python, and then the comp interpreter will come. Now, if it's not installed, what will happen is that in Windows machine, if you type Python for the first time, I think the Google app will try to install it automatically, right? So it will be automatically installed, right? Any question you can really type in chat and so on. Let's think about. Okay. So I think box. Okay, that's fine. So I'll answer the comments, some of the comments about Colab and other things later on. But I'm just going through from the very beginning level. Okay, so if I type hello there, so you can see that hello there with a single quotation or double quotation, both will work, and then it will be typed in. So double quotes work too, that is also appearing. So these are the string literals, right? These text like single quotation or double quotation, and the number. The number can be integer or can be float, right? So all these are numeric literals, and the last twos are string literals. So check your understanding. So what you can really do, if you're really starting from the scratch, you can open the Google Colab or the Python like this, and then you can try to type the understanding. So for example, if I just type x equal to 5.1, so I'm just trying to see that, can you see the screens? Yes, I think you can. So, okay. So if you type 5.1, and then if you just type y equal to, x plus 2, right? And then z equal to, x plus y, for example. And then you can just type print. So result, I'm just skipping there so you can see the result. I'll try to explain how does it really work. I just try to explain. I just showed you that this is how, at the very beginning level, if you try to run the code, you can get some sort of confidence that, okay, I'm progressing, right? In terms of understanding how the code is working. However, we really need to understand how does it really work, right? So before jumping to that, you can try to answer into the chat so that which lines in the shown program contain numeric or string literals. So which one is the numeric? So definitely this one, right? The 5.1 and this one, and where the string literals? Who can tell me where's the string literals? Anyone? Yeah, line 4, excellent. So these are line 4, excellent. So these are the string literals. What about this one, numeric, right? This is the numeric, excellent. But just to understand that particular thing, I'd like to explain a few bit here, but I think that will come later on. So let's see. I'll start discussing that. So draw. So what happens is that when I put a variable, so these are the variables, right? X and Y and Z, these are the variables. So any variable is actually a memory address. So the best thing at the very beginning level is that we should try to draw when a piece of code is given. Definitely in the exam you can expect similar type of code. You should expect. Then what you can do is that you can really put like X, and then this is a kind of box which is the memory, RAM, random access memory, and space. And when I give 5.1, so the 5.1 is the value of this particular variable, right? And that value can be overridden, right? So I can see that y equal to x plus 2. So which means that x plus 2, this portion will be calculated, and the value will be under y. So which means that y is another particular variable, right? Another box. So the value of x equal to 5.1 plus 2 equal to 7.1. So 7.1 will be written in this way. So every line when we execute, we need to draw probably something like that. That will give the understanding clear. And second benefit is that if we do that practice, then any complicated code, we can really evaluate easily, right? Okay, and the next line, the line 3, z equal to x plus y, which means z is another variable. So another variable means this is another space. And then x plus y, the value of x and the value of y will be added. So if we try to add it, we can get 12.2. So 12.2 will be inside Z. And then print result. So the result text will be printed, and print Z. So 12.2 will be printed. So what I just showed is that this can be a good practice when we are dealing with a number of variables in the program. Then really for every line we can draw in this way, so that we can identify what should be the output at the end, right? So this can be a good practice if we can do in this way. Okay, now we can proceed with that. Which lines in the shown program contain numeric or string literals? So okay, we explained that. Variables. A variable allows you to give a name to a value, right? A variable allows you to give a name of a value. That's why we said about x, for example, or y or abc, anything. It is something like that. So any value. So if I say x equal to 2, then that value should be 2, for example, right? And so on. Okay, so you can think of a variable like a labeled box, right? So I think label box makes sense here, right? Variable names are decided by the programmer. The contents of a variable can change, right? So this is an interesting thing, that the value can change all the time. And this is the difference between the variable and a constant, right? So we'll see in English, we know that the constant is, is one of the things in which the value can be fixed. For example, the pi, right? The value of pi 3.41, and this is a kind of, non-ending kind of thing. Okay, so there are some rules for the variables. So we'll come to that point. Okay, how to create a variable? So a variable can be defined via assignment. So assignment means equal sign. So you can see that there is some equal sign. Suppose if I type day equal to Wednesday, so how does it really look like? So we can say exactly the same way, that the day, right? And this is the memory space. And inside, I can write it Wednesday, right? Wednesday, right? And so on. So once I do it, then if I type that day, then automatically the value will be printed, right? This is a very easy approach. Day, Wednesday. Now, you can just recall that a few slides ago, we really typed one interesting thing, that the print Z, right? which means that we can either do using print, or we can simply type, the day, then it will be printed, right? So in a command prompt, it can be done in this way, but not in writing the lines of code. Then actually we need to use the print command exclusively, right? But in a single command, actually we can do that. Wednesday. Now look at this line, that age equal to 28. So then definitely there is a memory space of age. The name of the variable is age, and this is the memory space. And when I type 28, it can be 28, right? And then if I type age 28, so age, then 28 will be printed. Now just try to imagine that if, for example, the next line, I do age equal to 30, then what will happen is that this 28 will be removed or overwritten, right? It will be overwritten with the new value of 30. So when this line will be executed, we can expect something like that. So then if you try to print the age, or if you simply type the age after that line, so if you type simply age, then you can expect the value 30 to appear, right? So this is how we can put value inside a variable using the assignment operator, right? Using the assignment operator, right? That is the interesting thing. Assignment in Python is performed using the equal symbol, right? Equal symbol, for example, x equal to 5, right? Now, one of the side point about in different languages, like there's one language called Python, or sometimes in SQL, in other languages, they sometimes use a assignment operator like that, right? So different language may have different things, but most of the popular language have absolutely this type of assignment operator, by which we can put a value inside a um, variable. Now, another side note is that, for example, if I type, say, x equal to y, I think we came across that before. So if I say y equal to 2, so which means that, y has a value of 2. And then if I type x equal to y, which means x is another space in which the value of y will be copied, right? So this is exactly what is happening here, right? This is exactly what is happening here. Okay, which means that we can really assign the value of a variable also, the way we can put a value inside a variable. Any question, just type in. So all these are very basic thing. I'm just explaining in a kind of elaborative way. Okay, in mathematics, like equal indicates equality. So an expression of a state like x equal to 5 means x is equal to 5, right? And that actually explained the value is assigned to the x. And in Python, equal indicates assignment and instruction. X equal to 5 means assign 5 to x, or store 5 in x, right? That we discussed using those pictures. Updating the variables, we also discussed that we can update a variable. So assignment can also be used to update the value of an existing variable. So in the example shown, x originally has a value of 5, but is later updated to contain 10 instead. So for example, if we see that x equal to 5, so when I type x, the 5 will be printed. Now I'm typing y equal to hello. So this is a string literals, right? It is a string literals, and that was the numeric. If I type y, the hello is printed. Now I'm actually typing x equal to 10. So when I do it, then I can remember that x has 5. So if we have the picture, like the variable notations of these, then we cannot be lost, basically, right? There can be many variables in the program, so we can deal with that easily if we draw the pictures by the side of the code. So x equal to 10, then if I type x, the 10 will be printed. Okay, so what should be the updating value of these, right? So you can try to I'm just trying to, so look at that thing. And this is how a program actually works, or a compiler works, right? So for example, you type that in a code, right? You type that in a code and you try to execute that. So x equal to 5. So you see that x equal to 5. So the variable x has the value of 5. And then go to the next line, y equal to hello. So you put, y and the hello. And then when you type x equal to 10, the 5 will be updated to the 10, right? And then if I try to print, then we can get the corresponding values, right? Okay. So you can also try that into the Python, for example, typing into the Python command here. You can exactly try to experiment those things. At the beginning level, if you're really a beginner, I mean, we should always try to practice that by typing in. That will give us the confidence, right? Okay, the variable name rules. So variable names must only contain letters, digits, and underscores, right? Only contain letters, digits, and underscores. Must not begin with a digit, right? It's an interesting rule. Must not begin with a digit. Lowercase or uppercase matters, right? Lowercase and uppercase matters. So for example, my variable, you can see that there are three things, right? My variables, so this m is small, and then the my variable and my variable. So all these are actually different in Python here, right? So lowercase and uppercase matters, which means that this variable is completely, so sorry. So this variable, my variable, is completely different than this one and this one. So all these are completely separate. Even a single letter, if it is uppercase or lowercase, the whole variable is a different memory space, right? So all these are different memory spaces and their value is different. So in week 1, there is a programming assignment that we'll be doing during the lab, in which we need to deal with the situation that the variable names are case sensitive, right? So lowercase and uppercase matters. So if we type a specific kind of spelling with lowercase or uppercase, the exact variable name needs to be used in the future in following subsequent lines, right? Otherwise, the compiler will not understand how did you get this particular variable, right? It will show an error, right? So I just probably try to explain that in a simple example. So let's see about that thing. So in the screen 1, so for example, if I type x equal to 2, the x equal to 2 is right. So if I type capital X, then you can see that there is an error. So it says that the name X is not defined. Did you mean X? You see, it just gives more help, right? So that is actually the compile time error, right? So that is actually throwing an error that X is unknown. So then if you type X, then it will be printing 2, right? So this indicates that the different cases matters, lowercase and uppercase. We need to be careful on that. It matters. Okay. Now, more on the rules. So these are allowed. So we came to know that, must not begin with a digit. Must not begin with a digit. So X, name 2, all these are allowed thing, and underscore is allowed. And underscore really is used a lot in naming, the variables, because you can imagine that when we write a big code, then we want to make sure that the every word is meaningful. For example, if I type street address, just try to understand that street address, then this particular variable, it makes sense, right? The whole thing makes sense. And after 6 months, or any other person, when they will know that street address, they will understand that this particular variable is probably used to hold the value of the street address, right? Some street address must have been written, right? So for example, if I type, say, SA, I mean, suppose this one, I mean, S address, right? SADDR, for example. Or maybe I try to make somehow bit of, um, more. I want to give slightly more clarification. SADDR, but still, after a while, I may forget it, right? What does it really mean, right? So the one of the best way to I mean one of the best kind of technique not to create confusion in the future is to put something like the whole thing, which is a meaningful thing. It may be bigger, but it doesn't matter, right? As long as we understand. And that actually is part of the readability factor. The readability of the programming is very important, right? And in the programming, we try to put comments to clarify, to explain the things, right? And that we should be doing in addition to the meaningful variable names, right? Even my age, this is also a meaningful thing, and this is also acceptable, which is started with underscore. Okay, on the contrary, these are not allowed. Like 2D map, why it is not allowed? Because it is started with a numeric, it's a number, right? It is started with a number. That is why it's not really allowed. Okay, and best minus score, hyphen, right? Hyphen or minus score is not also allowed as a variable name because it indicates probably a minus sign, right? That's why it's a kind of reserved. School slash work, because it's a kind of division, right? It is not also allowed. Dollar sign we can't put at the beginning. Only underscore is allowed, and there is no space allowed. My variable, there is no space allowed in the middle of a variable, right? So these are the things to know. Now, in addition to that, there are some reserved words. So these are the reserved words which have special meanings in the Python language. So there are some reserved words that have special meanings in the Python language, and reserved words cannot be used as variable names. Reserved words cannot be used as variable names, right? So and, as, assert, break, class, all these things. So I cannot say that, like class equal to 2. So if I type, say, class equal to 3, suppose I want to make some calculation based on the class. So this is a completely wrong thing because the class is a reserved order. Okay. Def. So def is used to define a function. When we'll start the function, we'll do that. Elif, else if, else, for loop. So these are some of the programming construct that we'll be using from next week, and so on. The global variables or true, false. These are the kind of Boolean values. Return, it is giving return a value from a function. While statement, with, try, all these are reserved words. So one of the thing is that when you use the Python compiler, like Anaconda, not the command prompt that I showed you like this, not this one, but even Google Colab, when you use the, I think the, yes, I think not, I think it's true that even in the programming, so you can see that I'm sharing the screen. An interesting thing, like if you use the Google Colab, so probably its size, I try to make it bigger. Yep. So you can see that the for loop, when I typed the for loop, it becomes automatically, different color, not the black anymore. But number is a kind of, text that, you can use anything, right? This is your own kind of variable. This is your variable, right? So this is a variable. You can see even if you hover the mouse, it is showing a variable, right? And this in is a reserved word, right? This in is a reserved word. For is a reserved word. So there's a loading type of thing. Let's see. So if I hover the mouse for, let's see, sometimes it can give the more information. And this elif, so it's a different color than black, which means there is a reserved word. So So I can't use them as a variable, right? Okay, now I'm going back again to any question, please type in or you can ask. So these are the basic thing. I'm just going through really slowly. Okay, so the few things are that the reserved words we can't really use. Selecting a variable name. So variable names are for programmers, not computers. So regardless of whether you name a variable x age or zz23v, Python will interpret your program in the same way. So there is no issue in terms of optimization. Like you cannot think that if I use a particular variable, the program will be faster or slower. No such things are there, right? It will just be interpreted exactly in the same way. So the only thing is the last line. However, good variable names can help make code more understandable to humans. That I discussed from the very beginning, that we should try to make the variable names good and well descriptive. I mean, not like a huge description, right? Even it doesn't make sense. For example, street address. So I think you cannot go more than that, right? I mean, it doesn't then look good. So whatever is, you can think that, okay, I mean, that's good enough on that. Then, you can just use that. It can be bigger, but it is a meaningful thing and it increases the readability of the variables. Okay. So look at this particular example, that S2SFG5, right, is a variable name. And S2SGF10, and then S2SFF, we're doing the multiplication, and then print S2SSF. So in terms of the calculation, this is exactly okay. It is giving the result of 50, right, doing the multiplication, but it is not readable. This is really, doesn't make sense. I mean, what does it really mean? Unless we put a comment. We can put some comment to explain that, but it doesn't look good. And any company anywhere, if we write the program for others, then they'll not be happy by reading the code. However, if you look at the right side, that width equal to 5, now it makes complete sense that this is the width of something. So width is a variable in which the value of 5 is there, and height equal to 10, and then we are calculating the area of the rectangle equal to width into height, and then we are printing the area, right? So these two programs above are equivalent to Python, but the one on the right is much easier to understand as a human, right? So this is meaningful kind of thing, right? That we want to see in our code, okay? And now, another thing probably, okay, so which of the following are the valid variable names? So if you can please type in the, into the chat that which one is the valid variable names, which ones? So the first variable is a paper, comma, scissors, comma, rock. So the whole thing is a variable name. Is it valid? Yes or no, right? And this is the first one, this is the second one, third. Yeah, so this is fourth and this is 5. Okay, so some of you typed in like 4, right? What about this underscore friend? Yeah, good. So one of you actually typed in. So this is also valid, right? Friend. So friend and Gekwe. So these two are actually valid. These two are actually valid. So variable names can't contain commas. So which means that the comma, this is completely wrong. Variable names can't begin with a digit. So this is wrong. If is a reserved word. So if can't be used. I think it makes sense, right? So this is how we can really, do the thing. Now, before jumping to the next step, I want to show you one beautiful application in the AI tool regarding the variables. So I want to go to the Gemini. I mean, I just shared the screen. So yeah. So I just type like the rules of defining a variable here, right? So I just type in it. So I just make it bigger. Now, this is really important because sometimes Python can change or any language can change, so it's really best to know all the details. So don't really, in the programming language, don't really 100% rely on the PowerPoint slides all the time, right? I mean, probably, it can be outdated and so on. But anyway, so even, I mean, I would not say that rely on the AI tool as well, right? So rely on the documentation from the Python itself, right? Because they actually provide the most up-to-date documentation. However, uh, because this is for a long time, the Python, so we can see the exact thing that they start with a letter or underscore. These are the applied, consist of alphanumeric characters and underscores, and these are the different variables. And we can't use and there are some examples given. So you can try to go through that. So these are the variable names, invalid kind of variables, right? So I think we can get more ideas on that. Okay, so I'm going back to the thing. Yeah, ask the audience. Okay, this is your task. What name might you give a variable which represents the cost of a product? Okay, so can you type into the chat that what name might you give a variable? So price, right? One of you said price, definitely price to give, and the product or product cost of product, all are good. Now you can just try to imagine. I got really few very good inputs. Okay, probably I can share that in the screen. That's really interesting. Then we can decide, right? We can decide. So I'm just sharing the screen in this way. So the first screen like this. So say price, product cost of product. I mean, definitely cost of product cost. These are kind of slightly more meaningful, right? Meaningful. Of course, in a smaller context, prices also make sense. Amount. Well, I mean, yeah. Um, Maybe the price, right? Or sometimes amount means the quantity, right? Then it probably indicates something different, right? So this is a matter of discussion and so on. Of course, one interesting thing is that in a software team, even to define the variables, to put a variable names, the programmers can discuss among each other to come up with a meaningful name that we are really doing right now. So product cost, time, well, I mean, I'm not sure. So yeah, all these are okay, right? All these are really, the meaningful thing. But my my question is that, or my focus is really, if you put underscore or not underscore, as long as the complete word gives some meaningful thing, right? That we can try to maintain, right? So if we see here, I think this is not here, but we came to a idea, right? We came to an idea. Now I go through the statement. Next content is statement. So a statement is a complete step. A program consists of multiple statements. When you run a Python program, the statements within are executed in a well-defined order. So often a statement takes the form of a line of code. So step-by-step sequence, right? So we have already seen a few different kinds of statements. For example, with equal to 5 is an assignment statement. Print area is a print statement, right? So we already know that, right? That this is an assignment statement and this is a print statement. If you can use any other name, meaningful name, these are the functions. So print is basically a function, right? You can write it down here, like I can say that is a function. Definitely come to a function later on, but this function of print is actually system defined function, which means that this function is already defined within the Python library. So I don't need to explain how does it really work. So Python already gave the manual illustrating that this is how I work and this is how I'm executed. So use me in exactly the same way. For example, they said that under the print, these are the parameter inside the bracket. So this parameter must be a string literal, right? String literal or numeric literal, like any literal we can actually put it, and the corresponding the value will be printed out, right? And this function this function actually, does the job. So I don't need to worry about how it is working. However, if we want to make our own function, then depending on the name of the function, we can say that this is another statement kind of thing. Okay, so this is the statement. And what are the common usage? So interacting with the Python interpreter, calling function. So if I say 23, so 23 will be printed. If I say y minus 5, it will be, this is also, from y 5 will be deducted. Max 100 and 200. So how I define a function, it depends on that. For example, if there is a max function that between 100 and the 200, find out which one is the maximum, right? And so on. But in a different way, I can actually define the function, right? That we learn over the time. Print statement. So technically a kind of expression statement. So used to display output text to the user, right? So for example, look at this interesting one that the week one mainly focuses on, week one lab mainly focuses on this type of problem, that print a single quotation or double quotation, both works. Hello, my friend. So that will be printed, right? And print x times 2, then the value of x will be multiplied by 2, and the value will be printed, right? And the value will be printed. Okay, so some of the common usage: defining a variable, updating the contents of a variable. So for example, what's happening here? This is the defining of a variable, right? Or updating the variable, depending on if it is used before or not, right? If it is not used before, if the minimum age equal to 18, so this variable has not used before, then this is called defining a variable. So we are defining this variable using the value of 18. And I think I explained using the diagram. Like a box of minimum age is a variable address, and inside 18 will be, we can write it down 18. And similarly, area equal to 2 pi radius, right? 2 pi r. We know the equation, right? 2 pi r. So we are using the star sign to denote the multiplication, right? 2 times pi times radius, right? So pi needs to be defined, and that total calculation will be printed into the area. So area is a variable in which the calculation will be printed. Assignment statements involve an equal sign. Remember, this is different to equal in mathematics. Okay, so this is a different kind of thing. Okay, now input statements. Technically, a kind of assignment statement. So what's happening here is that the input is a function. So why it is a function? A function is denoted by this bracket sign. So there is a start bracket and the end kind of bracket, right? There are two brackets, which means the start first bracket and end of closing the first bracket. So that means it is a function. So this function do some job, and this input is a really popular one. This really ask for input from the user. So when I use the input command, then the compiler will prompt for input. So when it prompts for input, so this inside the bracket, if I don't put anything, it sometimes can create confusion to the programmer, right? That's why to make it meaningful, we should try to put some meaningful thing like enter a color. So if I put enter a color using an input, then that enter a color will be printed and it will ask for input from the user. The user will give the input and that input will go to the C, right, to the C value. So I'll try to explain that. I try to explain that using our compiler. Then it would be easier to follow, right? So I just bring it here. Okay, let's see about the screen sharing thing. Okay, so let's see, I just do it here, right? So I can see that, sorry, I think so. Okay. Here. What I can do here, for example, if I say input, right? Then you see that after putting the input, there is something. So the user will not understand what to do, basically, right? But I know that it is the input for something. So I can put 3, then 3 is printed. So to make it more meaningful, for example, I can say that input, for example, enter your age, for example, right? Then you can see that enter your age. Of course, I need to put colon, right? So enter your age. So if we say that 20, so enter, then 20 is printed. Now I can put that input into a variable. So to do that, I can say that age equal to input, right? And then enter your age. Your age, right? And then what I can do is that I can put a colon and then a space. So that space will be printed and it makes sense. So look what happens really. So if I do that, then you can see that enter your age and there is a gap. Why this gap is appearing? Because of that gap that I actually put before the quotation, right? Before the quotation, the single gap. And now it makes more sense. So these are the thing, the fine tuning we need to really include, right? And then I can put 20, for example. Then this 20 will basically be entered into the age, right? And then if I type age, then I can see the value 20. Even if I do print age, then you can see the age is printed. So I think it makes sense that what we did at the end for the last previous statement is that age equal to input and quotation enter your age, then that value is really entered. So if you don't put anything inside the input parameter, the program will be executed, but it doesn't really, it's not readable. That's also lacking the readability feature. Okay, so I'm just going back to the thing, to here. Okay, so now we can see here is that uh, these are the interactive sessions versus scripts. Now we are jumping to another kind of dimension. So far we looked into the interactive interpreter session, either Python 3 or Python you can use. So you start an interactive session using the Python. So for example, that we actually went through, right? This is the interactive sessions. And at the same, in parallel, we can use the Python script. So we can write the code inside a MyScript or any something.py text file using Notepad or any other software. And then you can simply type Python and the file name, then it will also be executed, right? So, however, we really will be doing this type of a script using the Colab. Then in the code, in fact, we can put many comments, many discussions and everything into the Colab, right? And I talked last class on week 1 is that Anaconda is another software in which you can use the complete code, complete Python file, and then you can run that. That is sometimes useful to do the debugging the thing. However, in any way you can do the debug. So everyone has their merits, right? So whatever you like, you can use that. So this is an example of the interactive sessions. We already went through some examples. So x equal to 5, x plus 2. When we do that, then 5 plus 2 equal to 7 will be printed. Now I'm putting name equal to input, enter your name. Exactly that we did. then you put the name Billy, and then you see that this is an interesting statement that print hello is a text plus. So plus is actually concatenating function. It's called concatenation, right? So it concate. So it just join to a string. So it just join to a string, and then the value of the name is actually, it's a string literal Billy. So hello Billy will be printed when I put the plus sign. Okay. In terms of a script, this is a good example that we can put that command into the script, and then we can put into a folder. We can go to that folder, we can open the Python file using the command prompt, then we can run that using Python myscript.py, and then these commands will be executed one by another, right? One after another. Okay, so what I can show you, not exactly this one, but in Colab, what we can do, right? I'm just opening the Colab, and then I first copy the code, right? I just copy the code. So I just copy the code, and then I'm sharing the screen. So I go here. So you can see that these are the codes. I go to the end, and this is the output, right? So you see that automatically a new code. So I'm just putting a new code. So Control V. So it's not appearing. So I think if it doesn't appear, then in a notepad, we can try to copy paste. So it's a kind of, some intermediate step we need to do. Um, so I just copy it from a notepad and try to put it here. So I think you can see that, right? So it is what's really happened. Okay, any confusion, please let me know if you have any confusion. Okay, so um, we just put it there, right? We put it there, and what I really did, I just explain it clearly that this is string 2. So what I really did from the PowerPoint, I actually put it into the notepad, right? I just put it into the notepad, and I just copy and paste from the notepad. Then actually it works. It copied without any issue. Okay. Um, so so when I go here, I just run the play button, right? So if I click the play button, then you can see that automatically, it asks for enter your name. So you can say Billy, for example, and click the enter, and then hello Billy. So it is printed, right? It is exact, absolutely printed hello Billy. So I think this is how really you can work. So this is exactly the same as, copying a PY file, PYNB file, and so on, similar to that, right? Okay. Okay. Now check your understanding. What output will be displayed after executing these statements in the Python script? So please do that and type into the chat. Excellent. So yes, you said that Control plus Enter to run code on Go without pressing the play button. Excellent. Good. Yeah, you can also do that. Control plus Enter button. That huge actually said. You actually said, okay, done. Okay. So what is the output of that? So done, right? And the age will be printed as well. Age will be printed as well. So age equal to 36, print 36, and age plus 1, 37. So age will be ultimately 37, right? And print done. So what should be the output of that script? So 36 and done. Good. Hasnain said 36 and done. So this is how actually we can, execute a Python code. So 36 and done, right? So only the print statements produce the output messages. So even though line 3 contains a statement which produces a result, it is not shown. So this is an interesting statement that line 3, age plus 1, of course, the value of age has been changed. However, since we haven't printed the age, so it is not shown basically. However, inside the RAM, the new value of age is still preserved, right? Okay. Now we are moving to the naming conventions. So I need to be faster. Let's see. So we already discussed this useful thing that the meaningful variable names are needed. For example, if I type interest rate, so interest rate, which makes sense, right? So this can be a good variable, right? Interest rate. I mean, you want to make it shorter, as long as it is meaningful, everyone make understand it clearly, then it is a good variable name or the meaningful variable name. However, whatever variable you use, Python will calculate it regardless of the way you just define it. Spending a few moments to select good variable names can greatly increase the code reliability. So this line is really important. Greatly increase the code reliability. So spending a few moments to select a good variable names can greatly increase the code readability. And some companies, some software company really impose that it must be accepted, or you must discuss it to the supervisor to identify a good variable name. This saves time in the long run, right? So this is really an important thing, that this saves time in the long run. So look at these examples. Like if I say variable 110, variable 25 on the left side, variable 320, it doesn't make any sense really. And we are trying to calculate variable 4 by multiplying variable 1 and 2. And if variable 4 is greater than variable 3, then we print danger. So if we just do that in a different way, that acceleration equal to 10. So this is the acceleration of a car, of a vehicle, for example. And acceleration time equal to 5 seconds. So maximum safe speed equal to 20. So speed equal to acceleration times acceleration time. So 10 times 5, 50. So if speed is greater than maximum safe speed, then print danger, which means the speed of the car is above than the threshold, which is the safe speed, then print danger. So if you look at the right side code, it is 100% readable. It makes sense which variable is doing what thing, right? So this is what we can try to follow. And one of the interesting thing is that acceleration time. Sometimes to interpret a variable, you may need 2 words, 3 words, 4 words, right? So minimum is better, right? Like 2 words, 3 words max is okay. So in that case, we can use the underscore. We can use the underscore, right, to do that. Okay, so now there's another convention sometimes people use. I would like to, um, yeah, excellent. So one comment came, else print equal to safe. That's also good. So, okay, what I would like to say. I think this is the thing that underscore we can use that. Common Python naming conventions, multiple words in a variable name are separated with underscores, right? This is really, really vital. This one. Ordinary variable are named in lowercase with underscore is separating the words. So the all the lowercase current is equal to 20, equal to 0, for example, constants. So constants, if I want to use a kind of constant value in my program, for example, the famous G, right? This is the calculation of G, gravity, gravitational force, which is the value of G equal to 9.81, right? Which is the Earth gravity, for example. Then actually we can use the uppercase. So this is just a convention. If you don't do it, it will not make any complaint. It will execute. But this is a kind of convention that Python recommends, that we can use that this way. So Earth gravity 9.81, so that can be used within the kind of calculation, right? And so on. Okay, other naming conventions, where appropriate, you may want to adopt your own naming conventions, indicate units like time to time seconds, right? So this is really important. So rather than using time, we can use time seconds, underscore seconds. That means that if I say type, like, for example, time seconds, SCS equal to 25, sorry, equal to 25, then it means that, sorry, so if we do that equal to 30, that means that this is the 32nd. because we cannot put the unit, right? So sometimes it is a good practice to put the unit. It's a good practice. Participants, so rather than participants, I'm using number of participants, right? So if I say number of participants equal to 20, which means that 20 people actually attended, right? Password one, password two, I mean, rather than using that, you can say old password, new password, and so on. I think sometimes when you try to change a password, some of the applications show old password, new password, right? That even in the variable, in the backend, we can use this type of variable using underscore, which is meaningful thing. Okay, so we get, this is an interesting observation that we can put unit in order to do the thing. For example, if you just try to compare the previous code, like here, so this line, that 5, is it second or not second, not really clear, right? So it's better to put the seconds here, right? And even this 10, so this 10 is speed, of course, meter per second, we know that thing. Sometimes if distance is a meter, I mean, we can try to do it depending on the context. If you think that the unit is required to put in, we can do that, right? That will make sense depending on the situation. Again, remember that it is not mandatory. It is just improving the readability of the code. Okay, good. So comments. Comments, I would say that this is the most powerful thing. This is the most powerful thing in the program. And the comments are really vital for documentation of the program, right? For any programming, we need to document it well. We need to document it well. And the first approach towards good documentation is to put appropriate comments within the program. And that comment really makes the program readable. So it can be used to annotate code in plain English. Good variable names aren't always enough. So, of course, good variable names, we try to improve the readability, but that's not enough. We need to put the comments. In Python, a comment starts with hash and continues to the end of the line. So when I put a hash, so this hash, this is the one line of comment we can put. We can write anything, right? So even I can use the comment like here. So we put x equal to 5 and then put a comment, and then this is the comment, right? So it just works for one line of code. So you can't place a comment before code y equal to 7. So I can't do that. So you can see that if I put the comment, then the y equal to 7 becomes a comment. I cannot execute that line, right? So this is a single line comment, right? So okay. So this is how actually you can try to put the comments. So just one thing. Let's see. I'm just trying to find one thing. Comment in Python. So I'm just checking in Gemini. One interesting thing, single line and multiple lines. So same thing. So you can see one, I'll show you that thing. I'm sharing the screen, and in Gemini, I just searched that I can use a single line comments using a single symbol line of hash, multiple line comments. So again, I can use multiple hash sign, right? Sometimes we can, so you can see that um, the comma can be used probably factorial, so that can also be used in this way, or you can use the hash to do that. Okay, so you can get some ideas from there as well. Okay, so just going back here. Common use of comments. Explain to other programmers or your future self. Has a complex section of code, how it works. Leave notes about future work to do. Add a copyright notice. So this is really vital, right? Add a copyright notice or indicate the authorship, who actually wrote the code, on which date, right? The version of the program, and so on. Temporarily disable a section of the code by commenting out. So this is also really vital. Sometimes we can try to, disable a portion of the code by using the comments. So these are the application of the comments, right? So we can see some examples of using the hash sign. We can do multiple lines. So don't be afraid of writing comments which are longer than the asset code if you deem it appropriate. So sometimes comment can be bigger than the chunk of code. but feel free to do that. I mean, this is really, I mean, everyone will welcome that. More comments are really appreciative. Comments in the while future work. So to do, for example, these are the plans like to do thing, what we should be doing in the comment. That's a future kind of plan within the code, right? So you see that the calculation is happening and to do add histogram. So and a calculation we need to do in future, and then the program coding continues, right? This is what we can really do as a future work thing. Comments in the wide license information. So I think if you look at any existing code, you can find similar type of thing, right? So it's a big bit of, copyright information, license information, the link information, and so on that really you can do. Commenting out code. So, so we just did that by using the hash sign. We just commented out this particular code, right? And we can do that. Check your understanding. So what should be the printout? Can you please try? You can write it into the chat. So what should be the output of the y? So x equal to 2, 5 equal to x plus 2, y equal to 5 plus 4, and print y. But there is a y equal to y plus 1. It's a commented. So what do you expect as the print y? Let's see who can answer that. Okay, 9. Good. So one comment came 9. So x equal to 2. Okay, another 8. Another answer came 8. Let's see. We'll try to discuss, right? X equal to 2. So what we can do, I mean, this type of problem I can deal in this way, that x we can say 2, and then 5 is basically 2 plus 2 4, and y becomes 5 plus 4. So 5 equal to 4, 4 plus 4 8. So y equal to y plus 1 will not be executed, and print y. So 8 will be printed, right? So 8 will be printed. So what I did here is that if you can just do in this way, can't be wrong, right? One of the very good example in any programming quiz, any programming test, like in the final test, is probably the examiner will give a chunk of code and you need to find the output. So in that case, it's really good practice. If you can follow this approach, then you can't go wrong, basically, right? Okay, so this is one thing to remember. Okay, so we discussed that 8. So line 4 is ignored. Okay, I think we finished the first part of this lecture. Now I'm opening the next one. Okay, so just do that thing 2.2, which is the expression. Okay, so this one, expression and types. Let's see. So it's happening. Okay, so we'll discuss about the expressions, types, and example program. We'll do a program right at the end, a very beautiful program, temperature converter. Expressions. So an expression is a small piece of code that resolves to a value. That resolves to a value. Just one thing. Okay. So an expression is a small piece of code that resolves to a value. So some extremely simple examples are 42. So a literally involves to itself and my var underscore var. So it's a my own variable, right? That resolves to a value. So when I put 42, so it's a number. So it knows that it's a number, it will be printed out. But when I type my underscore var, my variable, then the value of that particular variable will be printed out, right? So look at this example. The highlighted parts of the code shown on the right are the expressions, right? So these are the expressions, right? Like 33.33, it's a numeric number, a numeric figure. Vendor is a string, it's a number, integer, right? Albums, this is the value of this particular variables will be printed. New albums equal to albums plus 1. We're doing the calculation. Value of these variables plus 1, and the new albums will be printed, right? So note that only the right-hand side of the assignment is an expression. So right-hand side of the assignment. So in the assignment, the right-hand side is the expression, and the left-hand side must be an identifier. For example, a variable name. So a variable name must be on the left side. A variable name must be on the left side. Okay, so only the right hand side of the assignment is called the expression basically. So expressions can use operators to compute a result. For example, 3.5 minus 0.75. So it resolves to 2.75 calculation, right? X plus y, it resolves to the sum of x plus x and y. So the value of the x and the value of the y will be calculated. R plus 1, the value of the r plus 1 will be calculated and it will be printed, right? If we want to print. Now, and really a very important components are shown here is how can we do the calculations, or what are the numeric operators used in Python, right? Even you can search in Gemini or ChatGPT to find out what are the other numeric operators are there, but these are the list, right? So an asterisk, so plus, minus, multiplication, division. I think we all know that. But if someone is very new to the program, we know that, this star sign, asterisk letter, that is this asterisk is actually used for the multiplication, right? So this is the new, probably very new for the programmer. That in programming we actually use. We don't use the small x x sign, right? Star. So some people can think that, okay, what about 2 into 3? So this is not right. So this is x is a x letter, right? So we have to use the asterisk sign, right? Asterisk sign to denote the multiplication. Division is used by that symbol. Now, when you use the division sign, there's an interesting thing. Like you can see here, that 5 divided by 2, it gives 2.5. So it gives the exact calculation using the decimal values, right? However, if we try to find out the modulo operation or the integer division, like we want to separate out the remainder with the the division value, then we have to use the double kind of division. So we'll see an example that of to that. Now, division, the exact float value, if you want to print, you can use a single division. Now, this is another new addition, and even in some other languages, we don't have that feature, which is actually found in Python, is the exponentiation. So, for example, if I double star, so look at this example, 2 times 3. So this is actually equivalent to 2 to the power 3. So 2 to the power 3 is represented by this 2 double star 3, right? 2 double star 3 is represented um, by this way, right? So for example, you can think, if I try to put a value like m power n, all these are variable. I want to do calculation like that. So you can imagine what you need to do, right? M is a variable, so define a variable, and n equal to another variable, then do the power. So do that exactly same as using the double kind of sign, right? You can think of that. Modulo is the remainder of division, which is used as a percentage, and integer division is that. Okay, we'll look at an example actually here, but we'll come to that point. So integer division and modulo. So recall performing division by hand in the school. So we'd get two results, the quotient and the remainder. Quotient and the remainder, right? So for example, when evaluating 7 division by 2 divided by 2, we might say that 2 goes into 7 3 times with a remainder of 1. So the quotient is 3 and remainder equal to 1, right? That we all know that, right? That is the really the common thing that we know. Now, sorry, just one thing. Okay, so here, how to calculate this particular thing? So to do that, we can use the double integer division. So it's a double slash. So if I put 7 double slash 2, it gives 3. And if we put the modulo sign, the modulo, it calculates the remainder, gives the result of 1, right? So by using this and this, we can get the quotient and the remainder. the quotient and the remainder. However, if you want to just calculate the exact division, we can simply use 7 times 2. Then you can get 3.5, right? The fraction. But if I want to separate the quotient and the remainder, we have to do that two operations separately, right? Any question you can ask that, but all these are actually self-explanatory. Self-explanatory, you can just practice that. Okay, now the second important point is the combination of expression, because in the mathematical expression, we know that an example like that, it must have some precedence, and we know that multiplication get higher precedence than addition or subtraction. We know that formula from our from the school life, from uh, childhood. Okay, so but how does Python decide which operator goes first? So in the above example, how does Python choose whether to do 3 plus 2 or 2 into 6 or 6 minus 1 first? So which one to do first? How does Python decide it, right? So each of the operators in Python has a certain precedence. It's called priority or precedence. So this is similar to the mathematics. So remember learning, PEMDAS, parentheses, exponents, multiplication, division. So we know these sequences, right, from our early childhood, that parentheses have the highest preference, and then the exponents, followed by multiplication or division. So anyone, multiplication or division, and followed by addition or subtraction in this school, right? We know that. So definitely, if we can find all these expressions, yeah, BODMAS, yes, correct. So when we get that in sequence, so this one is really important. Operators with the higher precedence are evaluated first. However, if we come across with this like 2 times 3 divided by 4, suppose, right? So since multiplication and, so of course this is star, right? Multiplication and, sorry. So what I'm saying is this is basically the star. So in that case, what is saying that operators with the same precedence are evaluated left to right first. So left to right. So in that case, since both are same precedence, so we have to calculate this first, and then with the result, we have to do the calculation. So from left to right, the precedence will continue, and that is more systematic, right? Way to follow, and that is really important, because if a question comes in like what is the output, then we need to follow with the same kind of precedence operator, the left to right kind of thing. So this one is really kind of important thing. From left to right, we need to evaluate. Okay, so this picture actually gives the idea that the parenthesis gets the highest precedence, right, for the calculation. So similar to the, PEM does this thing. And the exponentiation is the second priority. Now multiplication, division, modulo, and integer division, all are actually the third preference, kind of in terms of priority. And plus and minus has the lowest, addition, subtraction, right? So this is how the calculation actually works in Python, also in mathematics as well, right? So what should be the output? Can you please try to work it out? Later we can try to calculate together, right? So what should be the output of that? 2 plus 5 times 7, then integer division, first bracket 1 plus 1. Okay, and these are the, the operators precedence, right? So parentheses should be evaluated at the very beginning, then the exponentiation, then the integer division, then plus and minus. Okay, so everyone try. After a few results, 2 or 3 results, I can explain. So definitely we can see that this 1 plus 1 will be evaluated at the very beginning, right? Okay, okay, 19. So we got 19. So this is really right, 19. So we can see that 1 plus 1 will be evaluated as 2, and 7, integer division 2 is basically the remainder is, so no, my mistake. So what happens here, that's my mistake. So in this case we need to see from left to right, right? So since this one and this one are the same kind of precedence in terms of operator because they're in the same line, so we need to do the left side first. So 5 times 17, 35, then integer division of 2, which is 17. So 17 is the integer division, and 7 plus 2 equal to 19, right? So this is actually the important one. From left to right, we need to take the precedence. So if you don't maintain left to right, the result can be different. Okay, another important component, even for today's assignment, is the string concatenation. It's a really powerful thing. String concatenation. We can join the string, two different string we can join. So string concatenation means joining two pieces of text or string together. For example, bed plus room. It gives the bedroom, right? Simple kind of thing can be used to build a message to show the user. For example, name, Jeremiah, and print hello. I put a space plus name, then hello, Jeremiah. I mean, that will be printed, right? With this space. So if you don't put that space, then you cannot get the space here. So we need to be really careful on that, right? But what we can see here, that since this is a string, that two strings are actually concatenated, right? So this is an interesting point to ponder upon. Okay, and this is how the string concatenation works with the plus sign. Now, this is a really important thing, is that when I try to concate, so beware, you can't combine a string and a number using the plus operator. So a very common mistake happened at the beginning, even, I mean, while doing the program, it happens, is that we try to combine a string and a number using the plus operator. Then we'll actually discuss how to deal with that very soon, even in the lab. So for example, here we can see that my age is plus 28. So it shows the error like that. And this error actually helps the programmer to improve the code. So once an error happens, we don't need to be panicked. We just read the error. The error is always useful, right? It will give the ideas what needs to be done. So it's saying that can only concatenate string str, not the int, to the string, which means that somehow we can use the concatenate only string, which means that this 28, since it is an integer, it is integer because it's giving an idea, it's an integer. We need to convert this integer into the string, right? We need to convert that integer into a string, and then actually we can really add that thing. We can try to convert that string using a kind of type definition, right? So I'll try to show that thing. Basically, that would be useful. So I'm just typing that, then I'll okay. So you can see that what I really did is that will be useful basically. So you can see that my age is plus str, right? Str. I converted the 28 using the str command. So this is a kind of function in which actually it converts the integer to the string, and then no complaint has been shown. But if we really don't do that, sorry, we don't really do that, say I just put 28, then you can show the see the error, right? Which means that I need to convert that number into the string that actually we did. Okay. Now the second important component is the types, right? So these are the four popular types in Python. Str, we already discussed that example. Str is the string. So a string of characters or text. So hello, right? Hello. Integer, a whole number like minus 43. Float is a decimal points, right? A number with a decimal point. is float. And Boolean, so Boolean is always true or false value. Remember that this true or the false, the first letter must be the capital. The first letter must be the capital, right? Because in Python, we know that, the capital and small letter matters. They define it in this way. So today we'll discuss about integers, floats, and strings. We'll cover the Booleans in the next lecture. So what is integer? So integer or type int. So one interesting figure is the type. So look at this thing. So this colon, this point matters, right? This portion we need to focus on. Type, str, int, or float. So these are I think we discussed about that. These four are system generated or system level keyword, right? Reserved keyword. These are the reserved keywords, so we can't use them as a variable, our own variable, right? So these are the type for any data. So integer represent the whole number. So often used to represent the following things like inventory levels, how many stocks are there. So how many stocks are there? It cannot be really decimal points, right? I mean, in general, age in years. Of course, age can be fraction. I mean, but we can simplify that concept. Attendance, definitely attendance is a kind of integer, right? Full number. So, for example, the minus 43, 0, and 10,000, all are integers. Floating point numbers or the floats. So the type is actually float. So there is no S, right? Float. Have a decimal point and a fractional part. So it has two things. It has a decimal point and a fractional part, right? So often used to represent precise measurements, very precise measurements like temperature, percentage, price of a commodity, of a component like 22.5, 0.0, or minus 0.999 are all floats. All these are floating numbers or decimal points. Okay. Now, there is a very powerful function is called type, by which we can identify the type of a variable. The type of a variable or a value, we can identify that. So Python can tell us the type of a value or variable. So simply use the type function, especially useful in the interactive sessions. So x equal to 1, and if I types x, then it can define the input as class int. So it is an integer type. Type 3.4, it's a float. Type x plus 3.4, so x is 1, but it's a definite float, right? 1 plus 3.4 equals 4.4 is a float, so it is printing out the float. So by looking at the output, we can understand that this is what type this particular value is. Okay, so you can also try with Boolean, like true, false. You can see that the bool will appear, BOOL, which is the last one that we'll be discussing next time. So there's a difference between 20, 20.0 and 20 with single quotation. So you can see that the last one, there is a single quotation, right? Ended by single quotation. So single quotation is basically string. So 20 as a string appearing. So 20 is an integer, 20.0 is a float, and 20 is a string. Python sees these values differently. Python sees these values differently, and values of different types behave differently. So Python chooses what operators do based on the types. Now, can you try to answer in the meeting chat, what does this expression evaluate to? 1 plus 2. Excellent. So 1 plus 2, it will evaluate as 1, 2, right? What would happen if I could put an, so can you answer that, that suppose this will evaluate as 1, 2 together, right? But if I want to answer like that, I want to put a gap, a single gap, then what we can do? If I want to put a space, then either we can put a gap here or we can put a gap here, right? Either option. Good. So Bennett, you said that correctly. So we can put a gap anywhere, right? So these are the really, very specific thing that we need to be really careful on, in which level we want to make the output. Any question you can ask me, right? That's excellent. Good. So these are the important thing. So yeah, that explanation is actually given, and so on, right? Bedroom. So these are the the output and so on. So string concatenation using the plus sign. Now, type conversion. So to change one type to another type. So type conversion is the process of deriving a value of a different type from an existing value. So sometimes Python will automatically convert the types. For example, when an integer and a float are added, the integer is automatically converted into a float. Okay, so this is an interesting explanation. This is an interesting statement that when an integer and float are added, the integer is automatically converted to a float. Why? What is the explanation? Because the result must be the float. So if we, because the both types, when they do the calculation, they must be compatible. They must be same. That's why we need to do the change. For example, if you look at the example, x equal to 1, definitely it's an integer. But if I do x plus 3.4, Python converts the 1 to 1.0. Then they can do the addition very straightforward way, right? And then the output will be definitely the float, right? That makes sense. So this is a really an interesting kind of statement. So Python doesn't always know how types should be converted. So there are times, sometimes, we need to convert it explicitly. Of course, this is where we don't need to do it explicitly. Python will do it automatically. Python will do it automatically, right? So for example, if I do say 1 plus 1, then no conversion is needed, right? But only conversion is needed if I put simply 1.0. then then this will be converted to float. This will be converted to the float. This will be converted to automatically 1.0, right? So this is an interesting kind of point. However, uh, in some case, Python doesn't know what to do, but we need to explicitly mention that there are some times in which we need to deal with this type of function. And just minutes ago, we actually explained this function str, in which we need to explain. So if I try to, okay, so this example is here basically that converting numbers to the string. So if I type age equal to 28, my age is, age, this compatibility is not there. That's why we need to explicitly convert it to str, right? And then it will be printed. So converting numbers to strings can be useful for building the output message. Converting a float to a string will always include the decimal part, even if it is a 0, right? So any float, when you try to convert it to a string, the 0.0 will always stay, right? And so on. Converting strings to numbers can be useful for accepting the input. For example, enter your age, input age, right? So enter your age 28, right? Now this one is interesting, that age plus 7. So convert it to the integer. So we can do the int operation. Float apple. So this is an interesting that we can't really convert a string to the floating number. We can't, it doesn't make sense. It doesn't make sense. That's why it is not allowed. So if the string doesn't represent a number, Python will raise an error. So this is even the error makes sense, that couldn't convert a string to the float, couldn't convert. So by looking at the error, we know that this is not possible, right? Okay, so what value does the following expression evaluate? So please try to do it and try to write the answer. String 9 plus 1 plus 0. Let's see who can answer that. What should be the output? So 9 plus 1.0. Excellent. So any other answer? Let's see. Just try to. This is a really interesting example. Yeah, good. So if you look at this explanation that so first, since we discussed that this is an integer 9 and 1 is a float, so when you try to do the addition, this integer will be converted to the float. So 9 will be converted to 9.0, adds 1.0, which becomes 10.0. So when we try to convert this float into the string, then the output should be exactly as it is. So 10.0. So this 10.0 is the string. So this 10.0 plus 0 to string, we are trying to add it. So then the output should be 10.00, right? So let's see the comments. Couldn't be 10, no. So 10.00. I think the explanation is clear now. I thought that when I did the workbook. Okay. So any other question? I think it makes sense, right? Otherwise, I can explain it again. So this is an integer. Makes sense, right? So this is an integer and a float. So this will be converted to the float. 9.0 plus 1 is a 10.0. This 10.0 is a float number. It will be converted to the string, and we learned from the previous slide that when a float is converted to the string, the decimal points stays as it is, right? So the string is actually 10.0 plus 0. That 0 will be concatenated, right? And this plus sign always deals with the string. Both sides must be the string. So 10.0 and 0, the final result should be 10.00. Okay, good. So now the last example, right, is the task definition. So for any program, we are starting. Okay, that's okay. Yeah. So create a program that converts the temperature value from degree Celsius to degree Fahrenheit using the following conversion formula. Where C is the temperature in degrees and F is the temperature in degrees Fahrenheit, right? So this type of calculation, if we can do that, then actually it gives us the confidence. For the beginning level programmer, it always gives the confidence that now, well, I'm now able to do any program, right? Any calculation type program, right? Based on this understanding. So we'd like to write a program on that. So once you can do it, you can do other calculations, other programs as well. In any textbook, I think I talked about the textbook. Um, there's no, I mean, there are some recommended textbooks. You can find books from anywhere. But if you look at the exercise of the books, you'll find that a lot of, I mean, at the beginning level chapters, they actually give all the calculations type of program, and that actually boost up the confidence of writing the program, right? So we should definitely would like to write some of the programs in regards to the calculation that is practical to us in other areas of studies, for example. Okay, so 9c divided by 5 plus 32. So definitely we don't need to understand the function. The function is from the physics, right? Or in chemistry or in other areas, the equations are given to us. As a programmer, we try to convert that equation into a meaningful program so that the people in the respected areas, in the relevant areas, they can use our program to calculate, right? That is the thing we are doing. So C is the input, which is the Celsius, and we try to convert to the Fahrenheit, right? In Australia, we use the C, centigrade, right? And Fahrenheit in the US measure, and so on. Anyway, so input, what is the input? So first, we need to identify, if you can recall the flowchart concept from the week 1, we need to identify the input, then which are the kind of statements of the logic and the output, right? These are the things we need to identify. The first thing we need to identify, what are the inputs we need? So the first input that we need is the C. C is the temperature in degrees Celsius, right? And output must be the Fahrenheit. F is the temperature in degrees Fahrenheit. Examples. So if we put 0, then the result is 32, right? So 0, this 0, 32, 32. If we put 100 degrees centigrade, the result would be 212. If we put 22.5 degrees centigrade, which is kind of normal, not normal temperature, I mean usual temperature in probably in summer or something, 22.5, then we get 68.9 Fahrenheit, right? We try to write a program like that. So input equal to 100, then 9 times 100 equal to 900. divided by 5 equal to 120, 180. 180 plus 32 equal to 220. So this is how the processing actually is happening. Okay, so we can draw a flowchart of this particular program, and from the flowchart we can go step by step coding, right? So start and stop. Always, this is a rectangle but rounded shape, right? Input number always, kind of skewed kind of thing, kind of this shape, and slanted, right? Slanted type of thing. Input number multiplied by 9, whatever input we can get, which is a C, multiplied by 9, divided by the 5, added by the 32. So all these are step by step, right? And the output number is the final output, is the F, and the program is finished. So this is a valid flowchart. If you have any other comment, you can write your own comment, and you can imagine that. I mean, you can do that probably in a single line or something. I mean, some opinion up there, but as long as the flow makes sense, your understanding is okay. But using the multiple lines, actually, things are more clearer, right? It's clearer basically. Okay, so input 100 and the processing is happening in this way. So now we translate each flow into the Python. We would like to translate each of them into Python. So the first thing, in case of input the number, we can use input enter Celsius. We're asking the input, and that value that the user is typing in, it will go to the TC. Now, the question is it a meaningful thing? I would say no, right? But at the beginning level, that's fine. But you can put centigrade or something, whatever. I mean, it's okay, but right? So we get the input, and that input is always text or string. So we need to convert that into a float, right? Float, and then it goes to the X. The input is initially read in as a string type str. So this first line is always string that we need to be very careful on, right? So any input statement always give the input as a string. Remember that. That's why we cannot do the calculation based on the TC. We cannot do the calculation based on the TC. We can't do that. We have to convert it to the float. And that is what is happening here, float. So the float TC is converting into the float, and I put it into the X. Okay. So we convert it to the number type float. And the next line is I'm doing the calculation, multiply by 9. So the asterisk star means multiply by 9. So X times 9. So look at the previous line. The line is actually X. We get the value. And then X times 9. We put it into the X. Or you can put into another variable. It's okay. So you can also put, any variable of your choice, right? Any variable of your choice. You can do that, right? You can do that really. But we do the calculation because multiply by 9, and then whatever X value, we try to divide it by 5. So we try to divide by 5 and put it into the same value. So this is actually interesting that because you can imagine that these are the intermediate steps. So all the intermediate steps, you can really use a same variable because this is not really used. That is actually used. Because if you try to use a new variable on each line, there is no point of using the new variable. That is using actually more spaces into the memory, and that the overall program is becoming less optimized. But if you use the same variable, it is more optimized, right? Any comment, you can write it down. But anyway, so multiply, divide by 5. So same variable is used, and then added by 32. I put the same variable. If you, again, I'm giving the context very clear, you can use another variable as well, right? Whatever you like. At 32, you just put the 32 and then the output number. So definitely the X is the final output, right? So how can you output the number? You can output as a string. So definitely the X is a float, right? It is a float type. So I need to convert it to the string because I need to concate with the output. For example, if I say that the Fahrenheit, so you can see that this is a string. I need to add concatenate with a string, right? This must be a string. So since TF is a string, but the originally X was actually floating number. I'm converting to the string as the TF, and then I am actually concatenating to give a meaningful output. Yes, you're right. Yes, definitely. I mean, one of the comment came that could you do it as C times 9 divided by 5 using bracket plus 32 is a quick. Of course, it is quick, but what is the objective of this particular explanation is how you can transform a flowchart into a workable code. So that is the objective. That's why it is just lengthy, right? But if I could write the code, I could absolutely follow your idea, right? So that you said, definitely in one line you can do that, but this is kind of understanding. We are just trying to give an idea that how, the type conversion is actually happening internally. Okay, so I think then actually we can do this. So this is the kind of final kind of output. Of course, what you just said that these lines, we can do it in one single line, right? One single line. But this is just following up the flowchart, because in real life, equation can be more complicated, more variables can be there. Then we need to do the step-by-step approach to do the final kind of coding. Okay. Check your understanding. So after reading user input, we converted the value into a float. Why didn't we convert to an integer instead? What's the answer? So if we do the integer, I think you can write down the answer. What's your, why can't we do the conversion to the integer? Because in integer, we can't really do that division. It must be a float number, right? Excellent. So cause we want precise answers with the decimal points, right? These are some of the comments. So I would like to share the comments here. So these are really good answers by you. So screen 2, no, screen 1. So these are some of the comments that precise answer decimal points. Yeah, good. So these are some of the things. Excellent. So I just go back to the expression. We are almost done. Now check your understanding that, okay, after reading user input, we convert the float into a float. Sorry, value into a float. Why didn't, oh, so we got that. Now, live demo. So this is another kind of really good example of, the Pythagoras formula, right? We all know that a square plus b square equal to c square, right? So c equal to square root of a square plus b square. Now, how to do the code? So look at that particular thing. So I just focus on that. I think, yeah, this is an interesting example. So you can see that a equal to, look at that kind of thing, that enter a. So I'm taking the input a and the b. So definitely a and the b, a is this. So enter a is the input function, and then I convert it to the float. So, the previous code, you can improve that in this way, right? We can convert to the float and put it into the A. And then another input, B, that is a string type of input. I convert to the float, and then I do exactly C. So C calculation is what? So A square. So this is actually A square, right? Plus B square to the power of 0.5. Because why? Why 0.5? Because we know that square root, sorry, what's happening? The square root of, say, x is actually x times 0.5, right? That is actually, we know that, right? So, right? That is actually equal. Okay. Okay. So that is actually done here. That's why we put the 0.5. And then the hypotenuse is strc. So since we're doing the string concatenation, since we're doing the string concatenation, I'm trying to convert to the string and using the plus sign. Okay. Now, is there any way we can simplify that? 0.5 in a different way. There is a function in maths. So I just put that import math. So probably I'll show a code here. I'll show a code here just to give an idea. Just an alternative solution, right? Alternative solution is that sorry, screen one. So alternative solution is that I'm just to import math, right? So then the math library is loaded. So inside the math, there is a function called math.sqrt, is a square root, right? Square root of say 2, I can get the result 1.41. So that actually we can do. Here, right? So I think it makes sense, right? It makes sense that we can really use the sqrt function rather than doing the power of square root of 2, right? So in both way, we can really do the solution. If you have any question, you can ask me. So I'm just trying to sharing the screen of that. So I just have written it that, so I must be smaller. So import math, and then you can use the square root function. Sometimes you need the square root function. So this is one way to do the solution of same solution of this, right? So so they are actually the same thing. They're actually doing the same job. Either you can do the power of 0.5 or you can use the math square root function. So math square root function is more simplified version. I would say it's a simplified version. In Java, other program language have the similar type of notation, right? Okay, I think I finished today's lecture, and this is one of the interesting thing. Is a summary, so I don't need to go through that, but we'll do the lab probably after 5 minutes, right? I'll close the line. I'll actually close the session, and you can open the same session after 5 minutes, right? We'll see you in the lab. Any question, you can ask me the question. Otherwise, I am closing the session. Okay, thank you all for joining today, right? So after 5 minutes, we'll be starting the same session, okay? Okay. Thank you all.